So what we've got here is a graph y equals f of x in the upper left corner. I'm going to call that graph A. You can kind of just see it's a little piecewise function. And then we have 7 other graphs that are rather similar to that first graph. So we want to match these different equations to the different graphs. All right. So here, our upper left-hand corner, that's our base y equals f of x. So this g of x is f of negative x plus 3. So what were our transformations for this? This inside negative sign here is going to reflect over the y-axis. And we have an up 3, right? So we want to see something that looks like the mirror image of our upper corner graph. And then it's been shifted up 3, right? And let's see, we've got 2 that have obviously been shifted up 3, F and H, but the only one that's been also reflected over the y-axis is F. So this has got to be graph F. So we're going to say, hey, this one is g of x. And I'll write it over here as graph F. All right, so next up, we have h of x, which is f of x plus 3. So this is just a vertical shift up. So I'm just going to write up 3. So we kind of already know which one this is, right? Because we said, well, there's only 2 that look like they've been shifted up 3 units, and it was F and H hadn't been reflected, just like this one. So this must be the graph of h of x, which also happens to be graph H. Okay. What about this one? We've got k of x equals negative f of negative x. Ooh, okay. So we have a reflect over the y and a reflect over the x axis. And you may remember that those two are 2 reflections together are the same as saying reflect over the origin or reflect about the origin. So i.e. reflect about the origin. Really, I'm saying the real question is this thing symmetric about the origin? So I don't want to say reflect about the origin. Well, it is. It's kind of the same thing. So if we start here and we say, okay, if I reflect over the y-axis, and let's say this point here is going to become just -2, -3 on the, if we just reflect over y, but then if we reflect over the x-axis, we're going to be at -2, +3. Looks like I got back on myself. So this one is an odd function. It's symmetric about the origin. So this k of x is actually graph A. So it's our k of x also, as well as f of x. All right, what about m of x equals 1/3 f of x minus 3? So we've got a vertical compression. So it's going to look kind of squished, and it's moving down 3 units. So we've got 3 of these that look like they are compressed. So we've got C, D, and E as options here. Now G, you can kind of tell here that G doesn't even match up because this segment here is not actually straight. So we're going to kind of like just knock it out of consideration for anything. So, we've got C, D, and E, which have vertical compressions are the only options. C and D have been horizontally shifted, but not vertically. E has been vertically shifted down 3. So this must be our m of x. So this is graph E. And then I think we have one more. Yes, we have n of x is negative f of x plus 2. So we have two transformations going on. We have a horizontal shift, i.e., and this one's going to go left 2 units. And we've got to reflect over the x-axis. So the graph's going to look upside down and 2 to the side. No compressions here. So let's see, which one looks upside down? This one is upside down. So is g of x. So is plot f. But graph f was vertically shifted. Plot G is the one where our origin point's been moved 2 to the left. So this is going to be graph B. So we're going to label this n of x. And that is the end of these examples. Your homework, go take a stab at your homework. All right.